Alright, simplest radical form, part 2, covering rule number 2 and then a little bit more. Now rule number 2, I write it in two different ways. It doesn't seem like it's the same thing, but it really is. No fractions in a radical, like this, or slash, no radicals in the denominator of a fraction, like this. Now, these are equivalent fractions, so these really are the same thing, so you have to keep both of them in mind. Basically, fractions and radicals are a no-no. The only thing you can do is you could have, say, a radical in the top and not the bottom. Now, by the way, these are not equivalent, what I just drew in red versus everything there that was in purple. Okay, so here is 1 radical 2. It happens to be one of our fractions from one of our slides, which said, this is equal to a couple of other things. And we're going to see what we need to do with that. Okay, we need to rationalize the denominator. So how do you do that? Well, it's like finding a common denominator when adding fractions. So if you had something like 1/5 plus 2/9, what are you going to do with that? Well, you're going to multiply this by, say, 5/5 and this by 9/9. Why would you do that? Well, you want to make the denominator the same thing, and then once you do, you can add the numerator. So in this case, we'd have 9 plus 10, and that'd all be over 45. So we would get 19/45. All right, well, that's not the problem I had in mind, but it's going to be something similar. See, this number 5/5, 5 over 5, that's the number 1. And this number right here, 9/9, that's the number 1. We don't have an equal sign so that we could do anything we want. All we could do is multiply by 1, but we can multiply by all kinds of 1s. So here I've got radical 2 over radical 2, and what's the purpose? Well, just like here where I wanted to get a common denominator, or a denominator that did something in particular, here what this does is it makes the radical in the denominator go away. Because the square root of 2 times the square root of 2 is the square root of 2 squared, or the square root of 4, which is 2. See? Radical gone from the denominator. So the numerator, we just multiply that and we're done. 1 times radical 2 is radical 2. And that is simplest radical form. Radical 2 over 2. Now, that is what I had right there. That was the simplest radical form for any of these fractions here. All right, a couple more. Now, this right here does follow rule number 1, meaning there's a perfect square you could find in it, and that might be of some help. You could find it early or you could find it late. But since we're working on rule number 2, let's just go straight to that. Square root of 75 over the square root of 75. Now, this may not be like radical 2 times radical 2 is radical 4 that you can do in your head, but you don't need to, because the denominator is the square root of a square, and the square root and the square cancel out. So the denominator will become 75. Now the numerator is 5 times radical 75. All right, now there are a couple of things that need simplified. 5/75, that's a rational number, and another rational number, that could be simplified. Plus there's something here that can come out of the radical. So which one do I want to deal with first? Well, it doesn't really matter, but here, what if I take 75 and divide it by 5? So let's see, that'd be 1 on top, and 5 goes into 75 how many times? It goes into 7 once with 2 left over, so that's 1/15. All right, 1/15 times radical 75. Well, there's no need for this 1 anymore. 1 times radical 75 is radical 75. Now, I still haven't dealt with the perfect square I said was in here. Have you figured it out yet? Well, 75 is 25 times 3, and 25 is a perfect square. And what is the square root of 25? Well, it's 5. So that's 5 radical 3 over 15. So if I had done that first, this 5 would have become a 25, and 25 75ths would have simplified. So I've got to simplify this again. 5/15. 5 goes into 15 3 times, so that's radical 3 over 3. Lots of work on that one. Okay. This one is not going to have quite the work at all. It just happens that it's a little bit easier. I can give each of these their own radical. Now, radical 3 is an irrational number, but radical 16 isn't. Why? Because the square root of 16 is 4. So it becomes radical 3 over 4, and it's done. So sometimes if you go a certain route, it's like a shortcut. Since I took the square root first instead of rationalizing the denominator, like I could have multiplied by radical 16 over radical 16 here, that would have been a waste of time. Square root of 16 being a perfect square, I didn't have to do the rationalizing the denominator step. Like right here is a rationalizing the denominator step. That's the thing that I do when I multiply this string by a strange form of 1. Okay, so if you thought that was strange, well, hold on, because we got one more thing to do. It's an addition. It's like an add-on to rule number 2. Leave no fractions in the denominator. I'm sorry. Leave no radicals in the denominator of fraction. So look how that's different. I've got a plus sign in this one. I've got a minus sign in this one. This is called conjugating the denominator. So what I'm going to do is multiply by 2 minus the square root of 18. Now, I can only multiply by the number 1, so I have to do that on top as well. Okay, so I made a box. What's that box for? Well, I've got a binomial, 2 plus radical 18, times another binomial, 2 minus 18, and, well, this is one way we've done it before. Now, I know, as I'm doing this, that I have a perfect square in radical 18, and I could have dealt with it first, but, it's like I've got options. I could, simplify one thing first or another thing first. So 2 times 2, 4. Square root of 18 times square root of 18. Well, one's positive, one's negative. That hardly matters. A positive times a negative is a negative. Now let's deal with the square root of 18 times square root of 18. It is not complicated. It's something times itself. It's a square. The square of a square root is the number itself. So that's 18. Now look at that. I'm going to get like terms in this diagonal. I will here as well, and in fact, they're going to be opposites. They're going to cancel out and just go away, and that's how the denominator gets rationalized. So I've got 2 times the square root of 18, and let's see, 2 times negative square root of 18. A positive times a negative is a negative. Negative 2 square roots of 18. Now if I add these together, that's 2 radical 18 minus 2 radical 18 is 0 radical 18 because you add the 2 and the negative 2 together. So that cancels out. I'm left with 4 minus 18, which is negative 14. That's what happens in the denominator. Negative 14. Now that negative I'm going to put off to the top or off to the side. Not in the bottom. We don't put the negative in the bottom. Alright, now the top, what happens? Well, it's a monomial times a binomial, so we are going to distribute. We distributed it on the bottom as well, but it was a 2 by 2, and we took care of that with this box. So I've got 6 times 2 is 12, and I've got 2 times square root of 18, and I've got that minus sign there. So minus, I said 2, 6 times the square root of 18. Alright, now it's finally time to take care of that square root of 18. I'm just going to switch colors here because I'm kind of going all over the place at the moment. Square root of 18, that's the square root of 9 times the square root of 2, and 9 is a perfect square. The square root of 9 is 3. But that is not a 3. That number inside the radical is a 2. So 3 radical 2. Square root of 18 simplifies to become 3 square roots of 2. That's rule number 1. Okay, so I can substitute that in right here. Now I've got the minus signs that I could take care of. I can distribute that negative to both the terms, and I have negative 12, and then, see, that negative 12 is right there, and then I've got a negative times a negative, which is a positive, or add. Alright, now there was a 6 right there. So 6 radical 18, if I bring that 6 down, what's going to happen is that 6 multiplies the 3 that came out, and that's going to be an 18 radical 2. So the second term here simplifies completely to be 18 radical 2. So plus 18 radical 2. And that's all over 14. Now there is something else I can simplify. You see how everything's even? Don't worry about that 2. You can't simplify that 2 with that 14. So I can simplify here 12 fourteenths and 18 fourteenths, and I get 6 sevenths and 9 sevenths. So here we go. There's our final answer. It's getting more and more complicated. All right, last one, number 10. Going to multiply by, well, you see how I had a plus sign here and I put in a minus sign there? Well, this time it's going to be 3 plus radical 27. So it's the two numbers you see, but with the opposite sign. That way you'll get this diagonal will cancel out. So I'm going to put the 3 and the negative radical 27 here, the 3 and the plus radical 27 here. Alright, so I already know these are going to cancel out, and they're going to each be a 3 times radical 27, but one's going to be positive, one's going to be negative, so you can go ahead and write it if you like, but they will cancel out and become 0, and I don't even have to worry about them. This diagonal, I'm going to get a 9 here, and here I'm going to get radical 27 times radical 27 is 27, but I do have a positive and a negative. So I've got 9 minus 27, and that's going to be negative 18. So out of all that, the denominator is negative 18. The negative is going to the top. All right. I could only multiply by the number 1. This 3 distributes to both of those terms, and I'm going to get 9 plus 3 radical 27. And still a couple things to deal with. 1, that negative. Here, let's deal with the negative first this time. Oh, I left it down here as well. That shouldn't be there. So the negative came up here. So I'm going to have negative 9 minus 3 radical 27 all over 18, but still not finished. Why? Because 27 has a perfect square in it. So how do we deal with 3 radical 27? Well, 27 is 9 times 3. 3 is prime, and 9 is a perfect square. The square root of 9 is 3, so it's going to come out. Now, when it comes out, it's going to multiply this 3 right here. So I have this 3. The square root of 9 is 3. And then this 3 stays inside. So I get 3 times 3 on the outside. It's 9. 3 on the inside. 9 radical 3. So I have negative 9 minus 9 radical 3. Nice 3. 9 radical 3 all over 18. And just like last time where I saw everything was even, and I could divide it all by 2, I can divide all this by 9. Don't think about that 3. It's inside the radical. You can't simplify that. But I can divide everything by 9, so that becomes negative 1 minus 1 radical 3. 1 radical 3 is radical 3 all over 2. And done.